Hi. In this video, we're going to look at stoichiometry. And let me first of all introduce to you what stoichiometry is. There are basically two types of stoichiometry. There's composition stoichiometry, and you've actually already done that. You didn't know you were doing it when you did it, but when we were doing percent composition, we were doing composition stoichiometry, and that deals with the mass and mole relations between the elements of a compound. The second type of stoichiometry is reaction stoichiometry, and that's what we'll be dealing with here. In this type of stoichiometry, we're looking at the mass and mole relationships between the products and reactants in a chemical reaction. So before we get started on that, let me just go through a couple of things. Your book deals with, it actually says that there are 4 different types of reaction stoichiometry problems, and they deal with each one of them separately. We're not going to do that. I'm going to give you a method for solving these problems that will be the same no matter which type of problem you're working with. And so it's not going to be real important exact to identify the type of stoichiometry problem that you're working on before you start solving it. I will give you a chart, and you will just use that chart to solve all your problems, and or at least all of your stoichiometry problems. But you don't need to determine what type of reaction it is first. All right, so there are 4 different types of reaction stoichiometry problems, and they're classified according to the information given and the information that they're asking for. For example, if you're given the number of moles of a reactant that is provided, and you're asked to determine how many grams of a product will be produced, that is a mole mass problem, because you're given the number of moles and you're being asked to calculate the mass of the product. So there are 4 different types of problems: mole-mole, mole-mass, mass-mole, and mass-mass. Now, as I said, according to your book, each one of these is a different type of problem. We're not going to deal with them that way. We're going to look at it a little bit differently. However, it's a good idea for you to understand what they're talking about when they talk about the mole ratio. So I'm going to introduce that here to you today. In a chemical reaction, the coefficients give you the relative amounts, the mole amounts of products and reactants. And so if you look at an example, a sample problem might be the reaction between calcium and oxygen. Like this. Okay, so you can say that 2 moles of calcium will react with 1 mole of oxygen to produce 2 moles of calcium oxide. And we get that directly from the coefficients. You can also write this then as a mole ratio, and I'm going to write it like this: 2 moles calcium to 1 mole of oxygen. We can also write 2 moles calcium to 2 moles of calcium oxide. We can also write 1 mole of oxygen to 2 moles calcium oxide. And you'll see what I've done here is this one right here. I'm going to just label these first, second, and third elements in that reaction. In some reactions you'll have 4, but you'll notice I have first to second, first to third, second to third. So those are actually half of our possible reactions. The other half, of course, is just flip them over. So we can also write this one then as 1 mole O2 to 2 moles calcium, 2 moles of CaO, calcium oxide, to 2 moles of calcium, and 2 moles calcium oxide to 1 mole O2. And there I have all the possible mole ratios for that chemical reaction. All right, let's take a look at another example. And for this one, I'm going to give you a bonus. Those of you that are taking the time to view this video, you will not have to do this one in your homework. The homework questions, this is the one of the questions involved in your homework. So when you get to this one, just skip it. We have 4NH3, that's ammonia, plus 6NO, that's nitrogen monoxide, yields 5N2 nitrogen plus 6H2O. Now here you'll notice that we have 4 elements in our equation. In this first one we only had 3. Now we have 4. That means there's going to be more possible ratios. All right, and I'm not going to label these like I did first, second, but you've got the 4NH3 is the first one, 6NO is the second, 5N2 is the third, and 6H2O is the fourth. So we'll start writing our possible ratios here. We have 4 moles NH3, that's first to second, 6 moles NO. Then we have first to third, 4 moles NH3 to 5 moles N2. And then first to fourth, 4 moles NH3 to 6 moles H2O. Then I'm going to go to my second one, 6 moles NO to 5 moles of N2. Okay, so I'm doing second to third and then second to fourth. 6 moles, NO to 6 moles H2O. And then my last one will be third to fourth. 5 moles N2 to 6 moles H2O. All right, and so there's all my mole ratios that way, and then of course I have to flip them all over, and so flipping each of these over we get 6 moles NO to 4 moles NH3, 5 moles N2 to 4 moles NH3, 6 moles H2O to 4 moles NH3. You can see how this is just busy work when we have to write every single one of these. 5 moles N2 to 6 moles NO, 6 moles H2O to 6 moles NO, and the last one, 6 moles H2O to 5 moles N2. And let me just make one comment. You'll see here, for example, in this one right here, 6 moles H2O to 6 moles NO. We leave our ratio like that. Do not reduce the ratios. Okay, there's a lot of them here that you could reduce. The very first one, 4 to 6, but do not reduce it. Just leave it in this form. Okay, so we'll leave it as 4 to 6. You don't want to reduce that to 2 to 3. Okay, that's that's unnecessary. Okay, so that's how you do your mole ratios. That's all that's involved. And as I said, listing every single one of them is it just gets to be busy work. And because we will not be using these, we will use them, but our chart will take care of them for you. And you will not need to actually write out the mole ratios. Okay, that does it for section 9-1. Thanks for listening. Have a good day.